Welcome to another JPJ Discovery video. Time travel. Is it possible? Science says time travel is possible, but probably not in the way you're thinking. You're doing it right now, hurtling into the future at the impressive rate of 1 second. You're pretty much always moving through time at the same speed, whether you're watching paint dry or wishing you had more hours to visit with a friend from out of town. But this isn't the kind of time travel that's captivated countless science fiction writers, or spurred a genre so extensive that Wikipedia lists over 400 titles in the category Movies About Time Travel. In franchises like Doctor Who, Star Trek, and Back to the Future, characters climb into some wild vehicle to blast into the past or spin into the future. Once the characters have traveled through time, they grapple with what happens if you change the past or present based on information from the future, which is where time travel stories intersect with the idea of parallel universes or alternate timelines. Although many people are fascinated by the idea of changing the past or seeing the future before it's due, no person has ever demonstrated the kind of back-and-forth time travel seen in science fiction or proposed a method of sending a person through significant periods of time that wouldn't destroy them on the way. And as physicist Stephen Hawking pointed out in his book, Black Holes and Baby Universes, the best evidence we have that time travel is not possible, and never will be, is that we have not been invaded by hordes of tourists from the future. Science does support some amount of time bending, though. For example, physicist Albert Einstein's theory of special relativity proposes that time is an illusion that moves relative to an observer. An observer traveling near the speed of light will experience time, with all its after effects, boredom, aging, etc., much more slowly than an observer at rest. There are other scientific theories about time travel, including some weird physics that arise around wormholes, black holes, and string theory. Einstein developed his theory of special relativity in 1905. Along with his later expansion, the theory of general relativity, it has become one of the foundational tenets of modern physics. Special relativity describes the relationship between space and time for objects moving at constant speeds in a straight line. The short version of the theory is deceptively simple. First, all things are measured in relation to something else. That is to say, there is no absolute frame of reference. Second, the speed of light is constant. It stays the same no matter what, and no matter where it's measured from. And third, nothing can go faster than the speed of light. From those simple tenets unfolds actual real-life time travel. An observer traveling at high velocity will experience time at a slower rate than an observer who isn't speeding through space. General relativity might also provide scenarios that could allow travelers to go back in time, according to NASA. But the physical reality of those time travel methods is no piece of cake. Wormholes are theoretical tunnels through the fabric of space-time that could connect different moments or locations in reality to others, but highly theoretical concept. Also known as Einstein-Rosen bridges or white holes, as opposed to black holes, speculation about wormholes abounds. But despite taking up a lot of space, or space-time, in science fiction, no wormholes of any kind have been identified in real life. Alternative time travel theory is infinite cylinder theory. Astronomer Frank Tipler proposed a mechanism, sometimes known as a Tipler cylinder, where one could take matter that is 10 times the sun's mass, then roll it into a very long but very dense cylinder. The major problem is that in order for the Tipler cylinder to become reality, the cylinder would need to be infinitely long, or be made of some unknown kind of matter. At least for the foreseeable future, endless interstellar pasta is beyond our reach. Another alternative theory is the time donuts. Theoretical physicist Amos Ori at the Technion Israel Institute of Technology in Haifa, Israel, proposed a model for a time machine made out of curved space-time, a donut-shaped vacuum surrounded by a sphere of normal matter. General relativity theory, tested with the primary plane experiment with atomic clocks, is the 1971 Haffel-Keating experiment, which tested Einstein's theory of relativity by flying 4 cesium atomic clocks around the world on commercial airplanes. The experiment showed that the flying clocks experienced time dilation, diverging from reference clocks on the ground by nanoseconds, providing evidence for time passing slower for moving objects. Key findings: the flying clocks showed time differences compared to the stationary clocks. So, yes, Physics allows limited forms of time travel, though not the dramatic kind from movies. Keep wondering and subscribe for more interesting videos.